Who's up? Number 1, the central atom is the one with the highest electronegativity. Anthony? False. It's the one with the lowest electronegativity, not the highest. That's the one that's supposed to be in the center. Number 2. It is true. Hydrogen can never be a central atom. It can only share 2 electrons. So it can only share with one other atom. You can't put in the center of 3 or 4 atoms if it can only share with one. Number 3. Okay, false. Okay, there's no way your bonding pairs can equal the number of electrons because there's 2 electrons in every pair, so that would never match up. Number 4. False. We take on polyatomic ions, they have a charge, positive or negative. So if it's a positive ion, did it gain or lose electrons? It lost electrons, so you actually would have to subtract from A from your available. Next. Yes, you get 50-50. True. Okay, resonance does occur. If you remember, we did resonance. This is the nitrate ion. The double bond could be here, it could be here, or it could be here. All 3 are valid structures, and they all exist at the same time. So that's an example of resonance. Number 6. It also is true. And if you just noticed, this is the nitrate ion. This is the one we were talking about. Okay, it was in your unit packet. Number 7. True. This is carbon dioxide right there. It's got 2 pairs, or 2 double bonds. Number 8. Okay. False. Because it only includes valence electrons. Not all electrons are available. Only those in the s and the p orbitals. Number 9. True. Once again, if you looked at your unit packet, I think it's on that 2nd page, we did the sulfate ion, and the available worked out to be 32. So you should have that already. Number 1. A is correct. What does VSEPR stand for? What does the VS stand for? Yes. Keep going. Close. Valence shell, so we're talking about the electrons in the outermost energy level. Electron pairs, electrons come in pairs, and they repulse each other. They push each other away. So this goes from being a 2-dimensional figure, which might look like this, to a 3-dimensional figure. They have to get as far away from each other as possible. So that means that the pairs repel each other as much as possible. D. That's the whole basis on our molecular geometry. Number 3. It is a tetrahedral. It is an AB4. One central atom and 4 bonded atoms. So if that helps, if we want to go back to this table real quick, as a reminder, this was an AB4. AB4s will always be tetrahedral. If you understand that, that will help you. If not, then don't try to use this. This is 3 bonded atoms and 1 lone pair. It will always be trigonopyramidal. As 1 central atom, 2 bonded, and 2 lone pairs will always be bent. And then a central atom and 2 bonded atoms will always be linear. So if you understand that, it's a nice way to help you. Number 4, Victoria. Pardon? D, linear. Okay. Number 5 is a AB3E. Go ahead. All right, it's so trigonal pyramidal. Number 6. C is correct. Unequal sharing results in a polar covalent bond. Yes. We're going to go further than that. D, ionic. It depends upon when we say greatly differs on what you're interpreting that as, okay? Number 8. C, when we're sharing them equally. It's nonpolar. Number 9. B. Okay. Ten is also B. The whole basis for 9 and 10 is to say it's not just the bond that determines it. It's not just the shape that determines it. It's a combination. You need to know the polarity of the bond, and you need to know the shape of the molecule to determine whether the molecule is polar or nonpolar. Number 11. Of course it's D. On our table here, we have water, right? It's a polar bond, polar molecule. Number 12. B is correct. Overall, it's nonpolar. That's just a tetrahedral. So the bond could be polar, but they're all pulling equally. Number 13. D is correct. Okay. And it has a lone pair on it, right? Okay, fill in the blank. Number 1, chemical bond. Okay, valence electrons. Number 3, makes it more stable. It lowers the energy level, overall energy level. Okay, good. Ionic bond. Somebody want to help her out? Covalent bond. Okay, nonpolar covalent. Number 7. Number 7. Electronegativity. Polar. Number 9. It is ionic. And number 10. Resonance.